Now let us see one more property of solid, liquids and gases, and let us concentrate on the property compressibility. So what is compressibility? It is change of volume when you apply pressures on solid, liquids and gases. So whenever there is a volume change that happens with the application of pressure, we say it is compressible. A relative change in volume of a fluid or solid as a response to a pressure change. Now in order to understand the compressibility of solids, liquids and gases, I am plotting a curve here of pressure versus specific volume, and we will try to compress solids, liquids and gases from 0.1 MPa or 1 bar to 0.2 MPa or 2 bar. So pressure ratio of around 2 that we will see. Now let us apply using a small experiment which I will show here using animation, and what we will do is basically take a very specific mechanical engineering application example, that is the cylinder and piston kind of arrangement. Alright, so this is my cylinder piston arrangement, and first I will try to compress the gas because we want to study the compressibility property of the gas. So this is my point 1 from where I start the compression. I will compress this gas, as I said, from 0.1 to 0.2 or 0.1 MPa to 0.2 MPa. So now if I compress the gas from 0.1 to 0.2, and if I say that the temperature during this compression remains the same, that is isothermal process, then let us see what happens. So I compress this gas from 0.1 to 0.2, and you can see the relative motion that happened when I had a medium of gas for compression. The piston could travel almost half distance, and what you see from here is a volume change that happened when I compress the gas from 0.1 to 0.2. Because the pressure ratio is 2, the change in volume that happened from V1 to V2 is almost of the order of 50%. So if I say temperature remaining constant, I will say P1 V1 is equal to P2 V2, and therefore P2 upon P1 will be equal to V1 upon V2, and what you say therefore is a 50% reduction that happened if the pressure ratio is of the order of 2. It means that when I compress the gas, there is a very appreciable change of volume that happened in the gas volume. It means that gas is definitely compressible. Now if I repeat the same experiment for liquids and gases, we can see relative change in the compressibility that happens as compared to the gas. Now I will do the same experiment, but I will have liquid in the cylinder piston arrangement, and I will again try to compress the liquid now from 0.1 to 0.2 or from 0.1 MPa to 0.2 MPa. That means I will keep the same pressure ratio. So this V1 could be assumed to be the same as given V1 over here, but just because I want to compare how the liquid behaves during compression, I am showing this V1 separately at other point, but please assume that this given value of volume at V1 is same as this. Now herein you can see that if I take liquid as my medium here for compression, there is hardly any change in the volume that happened as compared to the gases. We had only some ppm level change that happened in the volume, and the piston hardly moved as compared to gases where the reduction was of several orders here, but in this case it is just 50 ppm. That means it is hardly anything as compared to this. Actually has been shown in an exaggerated manner. In comparison to gas volume change, this is hardly anything. I will do the same experiment now and have a solid as a medium for compression. Again the compression would happen from 0.1 to 0.2 and from 0.1 MPa to 0.2 MPa, and this shows that now I have taken solid as for compression in the cylinder and piston arrangement. What do you expect? When I do compression of solid, as you know, there will hardly any reduction in the volume of the solid. Let us see now it is on the graph. So when I do the compression from 0.1 to 0.2, you can see that this change in volume is just 1 to 5 ppm. So it was substantially here, it was just 50 ppm over here, it is 1 to 5 ppm over here. It means that the solids and liquids are hardly compressible. The change in volume is hardly noticeable as compared to that of gas. When I compress the gas from 1 bar to 2 bar or from 0.1 MPa to 0.2 MPa, for the liquids and the solids there is hardly any change in volume. Can I conclude something from this? If I want to have some approximation now, I can conclude that the solids and liquids are incompressible, while the gases are compressible. And if I now give the definition to the fluids are only liquids and gases, I say gas is compressible, but the liquid is incompressible. Thank you.